So thank you very much. Yes, I'm really excited to be here. You may not know it, but I am a resident of Switzerland. I live in Verbier most of the time. So it's a great pleasure to be here. And the talk today is about the essence of software engineering, the CMAD approach. So I will have a couple of things to talk about. First is just to talk about what is CMAD and what is essence. These are two concepts, but I would like you to know what it is before we leave this room. How many of you know what CMAD is? And how many know essence? Okay, I would say 95% at least didn't answer positively to these questions. But remember, when you, the rest of your life, you will always remember this was the first time you heard about these concepts, right? So I will introduce the concepts, and then we have two talks here. Welcome to State Club. It's a new way of thinking about software development and how you actually can measure progress and health in your endeavor. Having done that, we will talk about welcome to the world of practices, is how you actually can compose your method, your own way of working by composing practices, and how you in an organization as large as Google can actually be a continuously learning organization. So that is what it's all about today. First, what is CMAD? It's actually a community that we founded in 2009. It was, apart from myself, it was Bertrand Meyer, who most of you should know, at least Swiss people, and Richard Soley, who is chairman of the Object Management Group, which is a forum where new standards are taken. This CMAD stands for Software Engineering Method and Theory. It has originally, when we identify what is it that we want to do, we wrote the case for action. It's time to act. And we got about 40 signatories. We didn't ask for more. When we had got 40 or a little less, we said this is enough. It makes sense to do. And among these signatories, we find famous people from around the world in different areas, including computer science, software engineering, things like computer science. I think I mentioned that. So it's twice. We have basically any area, agile, pre-agile. So the whole community is, the whole area is really represented. 2,000 supporters have signed up for it. And we also wanted to have some customers, people who really say this is what we need, this is what good for us. So we have about 20 companies, Ericsson, IBM, Microsoft, not yet Google. Maybe that can be the outcome of today if we do a good job. We also have 20 academic signatories, meaning universities, that are using it for education and for research. There is a quite large community of people searching for a new theory in software engineering, general theory in software engineering. And they are publishing themselves quite a lot based on work being done here. 7 chapters of CMAD in China, India, Japan, Korea, Latin America, Russia, and South Africa. And a chapter is created if you have a distance in a way, for instance, geographical distance or language distance. So many of these don't speak English so well, so we need to have a chapter. So we initialized the whole CMAD with a case for action. It had two parts. First was that we said that software engineering is gravely hampered by immature practices. And second, we support the process to refine software engineering. It's a quite a dramatic statement. We want to refine it. Actually, it's easier than that. We didn't have a foundation in the first place, so now we are going to create the foundation. What is software engineering? A specific problem we identify is that we have a huge number of methods and method variants with differences little understood and artificially magnified. You know, every methodologist magnifies his own work. That is part of the game. And another refounding, we said we need a kernel of widely agreed elements. So we need to find these things that are universal for all software development. So a kernel of widely agreed elements is what we felt we needed. And that is what CMAD has been working on for almost 5 years. And we can see the result now. So why? Why do we need a kernel of widely agreed element? Because we have no common ground. When you teach anything in software engineering, you have to basically start from level 0. Maybe some terms you can use, but we don't have a vocabulary. We don't have any foundation. So that was where it all started, basically. We don't lack methods and practices. How many methods do we have in the world, do you think? It's at least more than 100,000. 100,000 at least. So it's quite many. The problem is we don't know which they are. We have no way to learn from one another, really. Even in a big company, you may have 25, 30 different methods, and people working with in one area of a company cannot move, even if they are very professional, 10 years experience, cannot easily move to another area because we have no common ground. They have to sit on the school benches. I have done it. I know how it is. It's terrible. You have lots of experience. The young kids started yesterday, or maybe a year, know much more than you do because they know the language of this organization. That's not good. We don't take care of our best people. So every one of us knows how to develop our own software. But as a community, we have no widely accepted common ground. That is a dilemma. So if you see here, we have all kinds of methods or practices. User stories, use cases, Scrum, CMAD, waterfall, whatever. But they are isolated islands. You learn one area and then you cannot easily move over to another. Do you recognize this problem? Those who are senior here? Okay, good. It's significantly more than the positive answer I got the last question. So anyway, what we want to do is build bridges between these. So you can easily connect them. And basically, such a foundation we want to create should not compete with these ideas. They should still be there. They are still good, but they should help us to have a common ground for them. So basically, what we say today is that we power these technologies. We improve them. We make them more effective by using Essence as a platform. Because Essence is the result, it's the first result of a CMAD. So yes, this is the first result is we call the Essence kernel. So this is a common ground on top of which you can build practices. 1, 2, 3, 4, as many as you want. And you will see more about that in the next presentation. These practices can share things. They can also be composed, and the overlap will disappear. Be nicely integrated practices. The interesting thing is, though we have 100,000 or more methods in the world, we only have a couple of hundred practices that are documented, that are described. So, and basically, one of the most important discoveries we did 10 years ago is that basically every method is just a composition of practices. So every method is a soup of practices, because when someone creates a method, they do take what they like and understand. Not to forget that you don't understand everything, so you just take what you understand, and you make your own soup, and that soup may work. Usually because you have good people, or it doesn't work. So this common ground is what we call the kernel, and we use this notation to talk about the kernel. So what is now the kernel? What's inside this kernel? Well, the most important things are what we call the alphas. Alpha is a new term. We have never had that in the software engineering community, so it's a new concept. You will see why it's new as I go on. So these are the things we always have, always produce, and always have when we develop software. We always have stakeholders, people who want to use and consume what we develop. They have seen an opportunity, and the opportunity is implemented in a software system. Software system helps to address the opportunity. It fulfills requirements. So when you see this word requirements, don't think about the specification. Don't think about the document, because requirements are there even if you don't document. When you build something, you have an idea, an intent, what you want to build. And this can be documented, it can be described, in many cases it is, but it doesn't need to be. So requirements exist even if you have no documents, just to take the extreme. You also have work to do to fulfill the requirements, and the work will result in updates and changes to the software system. You need a team. There's always a team to develop a software. Team may be only one person in the extreme case, but there's always a team. And then you always have a way of working, a methodology. Even if it's not documented, you always have a team applies the way of working, and the way of working guides the work. So these are things we have identified as always universal, something you always have when you develop software. They are, you shouldn't think about these as documentation. You can have a way of working without ever describing it. It's in the group, in the team, and I guess much software is developed without having a described method. We have 3 different concerns. You see, we have a customer concern, which is related to the opportunity and the stakeholders. We have a solution, that is requirements and software system. And then we have an endeavor, which is work, team, and way of working. These things progress independently. They are different, basically represent different dimensions of software development. Another very important characteristics of these alphas is that they have state, progression states. And so, for instance, requirements move through a number of states. From beginning, it's just conceived, and then it is bounded, meaning you have an idea of what the limits of a system are, and so on. So we move through 6 states for requirements. every state is defined by a checklist. And here to the right, we have a checklist for every state. And then we also have a little card for each state. So basically, we have two kinds of cards. We have cards for each alpha, each one of these requirements, software system, and so on. And we also have a state for each one of them. So each alpha goes through a number state. You may progress. A real good work means you progress all these things basically at the same time. Here's another perspective of it. Actually, this is a tool developed in Italy by some people at the university. They view, here in this picture, you see that these alphas represent dimensions. You have 7 different dimensions when developing software. If you forget one of them, you will take a big risk. So, for instance, you have so you see all these alphas I mentioned earlier represent one dimension. And when you work, you progress each one of them, basically in every iteration, in every sprint. You have to take consideration every one of these. There are more things you can have taken consideration, but at least these things. So one of the most important things here is the checklists. And the checklists are incredibly powerful. For instance, flying an airplane, it doesn't happen without going through checklists for many different things. And no one would sit in an airplane without knowing that has happened. I mean, we wouldn't fly. Surgeons have a checklist with about 19 different checks, asking things like, does the patient have a known allergy? And so on. And from the beginning, the surgeons didn't want to have this. They are qualified. They don't need to have checklists. They have been educated for many years. This is ridiculous. I have to do this. But the result is that the number of unsuccessful operations, meaning deaths, were reduced by almost 50% by just using this simple checklist. So, simple checklists save lives. Why not software projects? Of course. But we have had checklists in the software community forever. The problem has been with this checklist that they were asking questions like, have you written this document? Have you had a requirement specification signed by managers? And or have you done this job? Have you made this activity? That is really not give any real value, because you can write a document without having done anything really useful. People fill in templates just to have done the job. So these checklists are measuring real result achievements. So all questions in the checklists, in our case, are measurement of progress, independent of how you did it. If you use user stories or use use cases or use feature-driven development or any other thing, doesn't matter. You measure progress in a uniform way. So the great thing is that in an organization like Google, you could have many different projects going on, but you use the same way of measuring progress. Okay, you can add more to it, but you have a starting point by using this work. So this is work that has been done within the CMAD community. It's not the only work, there is more done, particularly with theory, in the search of theory for software engineering. But this is the most interesting to us in the industry. So it has become a standard. There is a book, there is actually several books, but this is one book that we have written about the essence of software engineering, which describes how to use this kernel in practice. So Essence is a kernel and language for software engineering methods. It's very agile, so it's easy to change, easy to do what you want with it, but you have a starting point. So now I'll get to the second section, which is about playing serious games, software development games. We call it Welcome to State Club, and how to be lean and agile with processes, checkpoints, and governance. You know, this is, of course, referring to a Fight Club by, what's his name now? Yeah. You all know who he is. And instead of the fists, we use cards. Here is a set of cards. It has not 52, but almost 52 cards, and they are used to play, and I'll show you how we play with it. We also have, in a team, we have a little bigger cards, so we put on the wall, so people can go and write on it in the team. So it's the same cards, but it's used on the wall, on the board, so you can actually describe where you are and so on. And of course we have a little smaller one. So there's for all tastes here. So we will do a couple of things here now. Show how to use these cards to build a health monitor. And we play two games, progress poker and chasing the state. Progress poker is to agree on which state are you. The team agrees in which state they are right now. And chase the state is that the team agree on where are we now totally, and what do you need to do next. So the cards are, we use these state cards to visualize the health of your software development endeavors. So basically, you can think of a scenario, you go into a team, you've never been there before, you've not necessarily worked with them, but you can, in quite a short while, get the team to agree on something where they are right now in a way that was very hard to express otherwise. You would have to express it in terms of documents or something that is more visible, more tangible. Here, this is even if it's tangible, it's more abstract. So it doesn't means that you have to agree on a particular methodology. You can use any methodology. You can use it for small teams, big teams, large organization. You can use it for any kind of software development project, any kind of application. The same thing can be used and is being used in a very concrete and valuable way. So let's look at this. So we are building a health monitor for be used by a team. We start by laying out the cards. So these are the alpha cards. These are the cards that describe every alpha and its states. So it's the it gives an overview of what states you have. So here you have a first state is that the stakeholders are recognized, and you see underneath, you cannot read it, but underneath are a number of checkpoints. You have to get to this state, you have to agree on that these things have happened. So it's recognized, represented, you have found the people who are represent the stakeholders and should have a say in what we are doing. And as in this way, you add more and more. Next line of alpha card, opportunity, and you have all the cards here. To the left, you have the alpha, the key elements that you have to measure, and to the right, you have the states, how far you have reached. So you start by looking at, take up one of the cards, and you go, you take one card, and then you will move it to the left of the screen. I'll show you later how it actually works. So what do you do? We had last year in Nashville, a presentation with an agile conference, and had about 80 people, and presented a case where we actually got some documents to start with and look through the documents. We had about 15 minutes, 10 minutes to look through the documents, and then they went in and evaluated which state are we in. And of course, these states cannot be 100% unambiguous, because it's just English. But the value is that they make you as a team to think about things. Have we reached this state? And what do you mean? What does it mean? Is a discussion point. What does it mean to reach this state? What does this criteria mean? Or this checkpoint? And the discussion results in an agreement in the team. And that discussion is more valuable than if there was a formal definition of every checkpoint would not give us anything of value. So you have some documents and collect these documents, and then you sit in the team and agree on which states you are in. So, for instance, you start by looking at the first card in stakeholder and see, are we recognized? Have they been identified? Is there an agreement on which stakeholder groups should be represented, and so on? And you check if they are approved. And if they are done, the first card on the top will move to the left. So that is something you do. You can take the next card. You see this? You see that little thing here? You see a shake? It took 2 hours to do. So then you take the next card and see if it's represented. Stakeholders are represented. Yes, 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 they are. Wonderful. So you move that to the left too. And then you get to a card where you find, no, this is not done, this is not done. We have not got the stakeholders involved. They don't do what they're supposed to do. That's a bad thing, okay? It's really good to force you to say this is not done. So we cannot really move forward. If we move forward, we take a risk. So we should be aware that we take a risk. So this card will stay where it was, not move to the left. And that way you go through line by line and agree on where you are. And some of these, you may not have done anything. For instance, there was no work done on the way of working. So you still have to progress that. And that means if you look at the card, you will find this is not done, this is not done. Oh, there's a risk. You should think about what do we do to remove that risk. Okay? So in this way we can show where the team has reached and help them to decide where to go next. Because obviously to move to the next card is where the team should go. This has been used in several organizations, actually quite many organizations around the world. Now, I have to tell you that this was first done in my company, Ivar Jacobson International, which is represented in at least 5 countries. I think it's more, but we have companies in 5 countries, not counting Switzerland, and which is where the head office is, by the way. So it's a Swiss company. And we have been working this for almost 10 years. So in my company, we did these things for 5 years. And then we said, no, this is not the right way to do it. This should be a standard. We need a standard, otherwise nothing will really grow. Because otherwise everybody will create their own kernel. And then you have no foundation. So if you try to describe practices on top of a kernel, which we will talk about in the next presentation. So this has been used but for 5 years it was used entirely in my company. Then we started to go to create this community, and when we did the community, we agreed to give away everything we had seen, but not push it. So when we started to work on the kernel, we didn't present our kernel to the others. We started to find a way to work on it. This is actually in China. It's a team working on internet applications, and they used these cards on the top of the They use the cards to measure progress, and they put them on task board, so they could all reason about it. They use these big cards that I showed you, but they were in Chinese here, and they were also in gray. They help the team to be agile. They help them to set goals for the sprint, and with retrospectives. So not only are these cards used to guide the team on what to next, but actually go into the team and look at where they are and what we haven't yet done. So create retrospectives. And they help us imagine the whole organization. In this case, there were many teams working in parallel, and we all used the same way of measure progress. And in that way, they could learn from one another in a way we didn't do before. So this was in China. This is Carnegie Mellon on the West Coast, which is a university teaching software engineering. And they had 28 postgraduate students that all were out working in the industry and wanted to come back to learn more. So they created 7 different teams of these 28 students. They could develop any application they wanted. They could use any methodology they wanted, but they used the Essence kernel to measure progress and health. So to the right, we have the different 7 teams and how they worked. After 6 weeks, they had reached different states. Some of them worked very balanced. They progressed each dimension, each alpha, in every iteration. Some of them focused on the early, more like a waterfall approach, which is completely okay. If you want to work waterfall, this works very well for that as well. But, of course, most people today would use it for iterative development. So this allowed the different teams to measure progress regardless of what practices they used, which practices used. And it helped them to discover problems early. Because, for instance, if the stakeholders were not engaged, they would get that question early and say, no, they are not engaged, so I cannot progress. And then they can say, we have to do something here, or we take a risk. So that is the first game we play, chasing the state. And there is another game here, and that is to, as well as you can show where the team is, the cards can also be used to create checkpoints to show where the team should be. So they use this use the cards and to identify where it should be. So imagine the situation that you have, you're developing software that should go to operations for deployment. You need to have support ready to take on ownership of the system when you get to that point. And the critical legal compliance requirements must be checked. So this is a real situation that you have. Wouldn't it be good to have a checklist that could be used to confirm whether or not the software system was ready for release? So how would you confirm today that this is ready for release with very little risks? It's not an easy problem. It's one of the problems we have is always to define the definition of done. When are we done with something? So in this case, we started by saying, which alphas do we care about? Software system? Where should it be? It must be ready. And ready is defined by a number of checkpoints. And requirements, well, it should be addressed and fulfilled. So this is where we want to get with requirements. Opportunity, addressed, stakeholders satisfied for deployment, and so on. So we go through, and all these things help you to agree on what should be done. So are these checklists sufficient? Not necessarily. For instance, you may want to have something extra, an extra checkpoint that you don't have. Yes, please.
You want questions now or?
We are going to give you 30 minutes for questions at the end, so it's better to save unless it's okay. So that will be as planned, and we hope you prepare a lot of questions because that is a real fun part for us. So if you, for instance, software system, you can add checkpoints that fit your organization needs. By the way, as you can understand, it's easy to scribble something on these cards if you want to add something. So it's very flexible. What we provide is a starting point for you. So you can start with something and learn from that, and you will definitely improve it. So it fits your needs better in the long run. So here is an example. You want to have a certificate in place before you consider the software system. And you just add it on the card. So as well as showing you where the team is, the cards can be used to create a series of checkpoints to represent your development life cycle and help with governance and compliance. So you can now create your own life cycle for software system. Usually companies buy into one life cycle pushed on every project you have, instead of having different life cycle, which you can have based on the kind of problem you're solving. So you know about these. Working in sprints, you have a iteration 0, where you set up a project and make a plan. Iteration 1 to n, you develop and test. You get feedback, and the iteration 9 is you release the product. After every such phase or step, there's something needs to be done. You need to know when you can move to the next step. That is not trivial to define. This is an example where you can use the cards, and I'll show you. This is another a very particular method to use for scaling agile by Scott Ambler. And he has 3 phases. Each such phase must have a definition of when you're done. It's not easy. It's not easily done. We have this thing where you have a lot of ideas and you find business cases and so on, and you have after the end of each phase there should be some criteria for when you can move to the next phase, because this is all about business decision. It's not about like iterative development where you sit and develop features, for instance, one by one. So you need to have phases. Phases are needed in software development. Here's an example from one of our customers, KPN in Holland, where they had an approach for with a number of phases. Each phase identified that something needs to be done. Before we started to work with them, and now I say we, I mean actually my company. So this was actually done before CMAD was created, or at about the same time as CMAD was created. So for every such phase, you had to deliver some document. And for instance, the decision to fund and was a couple of 100 pages of document you had to review to see if it was on. It was document based, and that is not a good measure. So instead we added these the kernel and the alphas. So you can see here that you have every row represents an alpha. The top row represents opportunity, and the green point represents what needs to be done. It's a state. All these little boxes represent states. So you need to have reached a particular state to be able to move from one phase to the next. So this was used here. The value was that, for instance here, opportunity. The progress of opportunity moves from state to state here over these 5 phases. So what we did is moved away from signed documents to recognized achievements, that you really can measure achievement without looking at the documents. So that was KPN. So in general, you can lay out your life cycle and say, I want to have, in this case, 3 different milestones or checkpoints: decision to fund, decision to go live, and decision to hand over. So what would, now using the cards, so what would you require to get to decision to fund? Well, you look at the cards and you come up with that the first 4 cards for opportunity must be fulfilled before you can fund it. And so on. You see the software system, you have 1 card needs to be achieved. You need to get the first state of the software system before you can fund it. Meaning you should have an idea of that there is a solution to the problem. And in this way, you can describe any life cycle using the cards. Very clearly, distinct. Something that is very hard to do if just use English or communicate with one another. As you see, some cards are lying down. That is the way we use when it's optional. If we need to get this state, it's optional. Here's another customer. This is Munich Re in Germany, the largest reinsurance company in the world, represented in United States, in Singapore, and I think in many other places. They started to use these cards, and here you see another way to represent it. It's a poster with sliders. So you move the states up and down the slider, and you decide to reach, and to the left you have a different states, different checkpoints. So in this case, you have 4 different checkpoints for a project, and you decide by how far you need to have reached to pass a particular checkpoint. Now, they found they have several different kinds of projects. They had one they call exploratory, and that is risky projects, new projects. We have not done it before. So they had a different milestone for that. You should have a lot of these kind of projects here. So you may have different milestones, different checkpoints that works for these kind of projects. Then they have a standard project. This is more like adding more features to an existing system. They had another, and then they said we need 5 checkpoints for this one. And small enhancements, that's maintenance. You make small enhancements. So they had another one. And they use the same cards to define these life cycles. So, and finally, for support, they use the same key ideas to define what are the different checkpoints and what is the definition of a checkpoint. Definition of checkpoint is done by specifying which states should have been achieved of the alphas. There is an app, unfortunately only on iPad and iPhone. I apologize. But this may change, can easily change after today. So and in this app you can actually also, you have a states, so you can click on it, and you can, for each of the states, you can check if you have reached it. So this is a tool you can use in your project. It's free. But the risk you take is that you like it. So there are particularly 4 things to remember of what I've just said. So this is basically kind of summary. CMAD relies on a common ground or kernel. We call this kernel essence. The kernel includes 7 alphas to be used to measure progress and health. So that's another. So this alpha concept is new to software engineering. It relies on a simple, intuitive, visual language. You know, we have so many languages in the software community. Some of them may know about UML. These languages are not easy to use. The tools are not easy to use. I remember when I worked at Rational Software that people said that the tools could only be used by PhD students. And whereas most people are not really interested in the technology, they want to have support. So we have been spending an enormous amount of time to finding a simple way to express ourselves. And that was one of the goals. And then that we play, the software developers played as CS games. On our website, I mean my company's website, we have 7 different games that you play in developing software that are really helpful in doing it. So now I come to the second major section of this talk. We welcome to the world of practices. Here I have asked a colleague of mine, Ian Spence, who is also working in IGI, my company, and who has been instrumental in the development of a kernel and what we have here. He is the guy who knows more than anyone else about how to use the kernel, the essence, and the practices in real situations. So, welcome, Ian.
Hi, good afternoon, everyone. Okay. So this is going to be a bit of a lightning talk, as we haven't got that much of the time left. There's a few things I'd like to add to what Ivar's been saying in the way we can use the kernel as a foundation to empower our software development teams to innovate and share their practices. And this is where we can act as a worldwide community to improve how software development works. And the interesting thing is, we're in a very competitive market. The world is changing, the technology is changing. We can't afford to stand still. This is not an option for the companies we work for, certainly not an option for a company like yourselves. Can't imagine you ever standing still. But we need to keep moving quickly and keep up with the times. And as companies grow, we need to be able to share those things that have helped us be successful with each other. And what you find in the software industry is there is this tendency to think there's one true way of developing software. There is one method. And what I want to tell you is that there is no one true way to develop software. There is no one method. The agile movement has given us lots of great things, lots of practices. But there's a worrying tendency for them to say these are the one true practices, tie them all together and produce another big method. Right? I mean, Ivar himself once tried to do the unified process. This was very popular for maybe about 5 years or more. But if you look at the practices in it, things like use cases, iterative, they still go 20, 30 years later. I've been in software development over 30 years now, and there's still some things I learned, there's still a foundation of things I do today. So if we can get and understand those practices, understand the circumstances, then every team's way of working becomes a collection of practices. And when teams are trying to do things that have never been done before, they will start to create new practices. Now, if those practices can play well with the others, then everyone can benefit from them. I'm sure many of you do Scrum in your projects. We had a little tour earlier. I saw at least one Scrum board and a board saying which week in a sprint people were in. What has made Scrum so successful and kept it alive? It plays well with other practices. It doesn't tell you how to do the requirements. Right? Now, when people pick up Scrum, they think they have to do user stories, for example. But you don't. You can do use cases. You can do features. I mean, I've spoken with Mike Cohen. He's done projects with use cases. Alistair Coburn is quite big in the agile market, and like me and Ivar, he's done books and things on use cases. But what you've got to do, and one thing Alistair does on all his courses, is he makes everyone swear an oath of non-allegiance. Right? We need to free the practices, make them independent. There are practices I know that have come out of Google in the areas of testing and other things that other people pick up and apply. But their environment is not the same as yours. They might need to have different kinds of controls. We're using different technologies. So if we can free the practices, we can create an industry where we keep competitive in our software development, we keep moving, and we can share with all our other developers and communities around the world. And that's part of the goal of CMAD. So, I mean, a practice is a very simple idea. It's just a repeatable approach to doing something. And what we've done with the kernel is come up with a way to make the practices be able to play well together, so you can see how they fit together. Do they complement each other? Do they conflict with each other? And a way of expressing them. So with the card idea, and I'm going to try and skip a load of slides now on the fly. Hey, so we have the card. So just like the kernel was put on cards, we can put our practices on cards. Just like the kernel had alphas in it to show you the big picture, practices can add ones to show you the little picture. If you're using user stories, for example, I suspect somewhere you have a tool where you can see whether they've been prepared, right? They're ready for done, whether they've been completed, whether they've been accepted. That's a classic case of an alpha. You'll have documentation to go with that, describing the story acceptance criteria. When you're doing activities like a workshop to find use cases or a workshop to find user stories, it will be useful to have one information to help you plan. How long is it going to take? Who should be involved? So we have activity cards that show that information. And they can also, the final one on the stack there, is a checklist for people undertaking an activity. Are you ready to start? Have you done the right things? Are you ready to end? And again, like with the kernel, you can use these to communicate with each other, to find out where you are, and to drive things forward. You can also plug and play with the practices. So this idea is very powerful. And just like surgeons benefit from checklists, this is, anyone know what that is? That is Buzz Aldrin's glove from when he went to the moon. He had on his glove a card, and on the card was a checklist. Right. So that him and Neil Armstrong, when they were on the surface, could coordinate their activities. This is what we're trying to do, provide the information that lets our teams work, communicate and collaborate effectively. So it's the same kind of thing. With this, you can, and with the kernel, you can bring your practices together, plug them together safely. You can look at there's some other things than just the alphas in the kernel. There's some maps of the territory that allow you to, when you add a practice, you can add information into the checklist in the kernel. So if you are doing use cases when your requirements are conceived, maybe you should have a use case model. So it all starts to come together and lets you, there's stuff to help you analyze and understand your practices. So I will skip over that a little bit. Okay, and this separation of concerns is key. You're mainly software engineers, so you'll all have software engineering practices you can share with your colleagues. But there are other practices in your business that you need to be cognizant of. Okay, there's always some kind of financial governance and time recording and things like that. Let's make that important, but not constraining how you develop your software. You're the experts on those things. And business practices as well. You have to work with your stakeholders in your business. How are you going to communicate with them? It's great to say we will talk to you every day, but it's not always possible. So you might want to add practices in those areas. So that's the key ideas is empowering teams. We're not trying to sell you a method, we're trying to sell you an idea that will allow you to explore and create and establish for your teams the best way of working to do that job and understand what is the best practice in your situation. You can't set up something that tells you the best practice in all situations, right? But look at their strengths and weaknesses. And this is the idea. So, I mean, there's a couple of other slides in here, but I think we can just, a couple of case studies with a company that had different life cycles and different sets of practices for different kinds of projects and customers. Another example is Fujitsu Services, where they set up a set of practices that they could use when they bid with their customers. That included both waterfall and iterative ways of working, because the customer gets to choose some of the practices, not the supplier. But it also helped them pull their tools together. By lining the tools up on the kernel, they ensured that they could use the same tooling regardless of which practices the teams were using, which then frees the teams from being, oh, I'm using this tool, I must use this practice. And it even got as far as cards appearing in their ALM tool, in Jira, that they use for their stuff. When they got a task, they could see the cards and the checklists that applied to that piece of work. Okay, so I'm sure you've got the idea. This is a powerful idea. It helps bring people together. It helps you build communities. Where do practices come from? They don't really come from people like Ivar and myself. They come from people like you, people who are doing the work, doing the innovation. What we do is we meet you and say, that's a good idea. We'll write that down and take the credit. Hey. Right. But let's get it so we can take out those middlemen and have communities and practitioners working with each other. Okay, so I hope that's been useful for you. Right, a bit of a lightning view over there. If you go hold the slide deck, there's some more detail on the different kinds of cards and things. But now I'll hand back to Ivar for questions and final wrap-up.
So, who wants to ask the first question?
I have a little bit more to say.
Okay.
Oh,
and then we get questions, yes. I will be very happy when we get to the questions. So just to give you some kind of conclusion here. CMAD is and the Essence have been going on since 2009. We started to write a paper for Dr. Dobb Journal in need of a theory in software engineering. That was 2009. And this theory basically was meant to get an understanding, a foundation. We developed Essence to standard. It was taken in June this year. Sorry. And we have this book, and there are a number of other books. We can highly recommend you to read this book. So what you could do is find out more about practices. You can go to our website, and now I mean IGI's website. You can also go to CMAD website, where you'll find a lot of material and papers published by many people and also working on. And so read the book. And playing the games, you can find the alpha state cards and on our website, and I see that there will be some cards like this available for you. And so you can go to LinkedIn to participate in discussions and uses of it. That's all we want to say. We are in 5 different locations right now. Have companies in 5 different locations in the US, UK, China, Netherlands, and in Sweden. So we are happy to now go over to the questions. Finally, the questions. So Ian.
Working. Thank you very much for coming and sharing with us. I want to preface that sometimes it's nice to understand something by probing how it's different than your expectations. So if it sounds like criticism, please just take it as engagement. I find that for a lot of teams here at Google, the goal isn't to win, it's more like to survive, or the way that well, survive and thrive, but in the way that pragmatic programmers put it, we're not really building structures, we're gardening, and we're trying to tend to things and make them survive and last and grow. A lot of these methods seem geared towards starting, progressing, and completing, which ignores the fact that we need to have maintainability and just long-term continued progression without ever completing. Could you please address how we would use that for that situation?
I think this is quite typical for a very successful technology company, which are moving very quickly. But eventually it will be necessary that you create an organization that is continuously learning from one another. And it's very hard to do in tradition. It has, in my experience, in so many companies that we have worked with, been very hard for companies to create an organization where people can continuously grow their knowledge and learn from one another. So this is one of the objectives of CMAD, to do that. But there may have been something more into your question that I didn't really grasp or comment.
Are these methods useful for understanding maintenance of a system that continuously improves and never completes? So all the cards never move over to the left?
So yes, I can let Ian respond. It seems to...
So an interesting thing about the kernel and the cards is it's about understanding where you are and then putting that in context. So you don't have to have a fixed life cycle, but you can understand what it means, say for example, for your software to be ready. Now, a lot of companies do continuous deployment, but you can look at the checklist to see if you've gone back. Right? Maybe you've forgotten a few things and actually it's not ready for deployment anymore. So you don't have to use them in a linear sequence. You can use them as a map to see where you are and then balance that against your goals and objectives. So they're useful in lots of circumstances in terms of having a healthy understanding in the team of where you are, who's involved, what's going on. So that can be helpful in those circumstances as well.
Are you okay?
Yes, that's helpful.
Okay. Yeah, you should stand here because otherwise we don't see you.
But that's a benefit for the people on the cameras, I always think.
I would like to follow up on this question. It also seemed to me that the cards, as far as we saw them, were mostly informed by projects that were just started and had to go to completion. So the question is, were these cards actually informed by projects of the type that were just described, that are very long-lived, that evolve for a long time over time?
Yes.
Okay, so maybe we just need to look more
okay.
closely at the cards.
So first, very important, as the second part of the talk that Ian gave, is about adding practices on top of a kernel. The kernel is universal. It's something that every project would encounter. So to reach to specific things, you need to add practices on top of a kernel. Every practice has its own alphas. It also introduces work products which are not in the kernel, and activities, things you need to do. So they are working over the whole life cycle, for not only starting, as you saw also one example, Munich Re has used this model to describe the different milestones for maintenance projects as well.
Okay. And I have an unrelated question. I can imagine that you can use CMAD to create a map of all the existing methodologies, kind of where their strengths and weaknesses. And has this ever been used to actually go into a team, look at how they're doing, and then maybe choosing a different methodology for them to compensate for the weaknesses that you observe in how they're currently doing?
Yes, definitely, in several cases. But this is where Ian is the expert, so I'll let him.
But one of the things that has been done most with the kernel is exactly that, to help a team understand the strengths and weaknesses of their current way of working and look to improve it. So I've used the cards just in retrospectives with Scrum teams, because I've never seen them before, but you've been going a while and you've taken your eye off the ball in some way. So you can go and see where you are, and you can take your practices, write what you do on post-it notes, stick them onto the kernel, and see, well, we have 50 ways of describing this, but we never talk to our stakeholders, as you see in some traditional organizations. So that's been used a lot in those areas. You can use these things without making a full commitment. You don't have to build a method. You can use them just to understand how your tacit way of working is shaping up.
And I take it these were successful interventions.
Yes, I mean, the good thing about when you do the card, you get a conversation started. So people find strengths and weaknesses in their way of working and things like that, and then they use that to drive improvement. So, yeah, I mean, they're very easy to use.
One of the most common mistakes that were done in China at one of the big companies we have been working with, a really big company, was that they didn't involve the stakeholder. So there was no thinking about stakeholders. They had stakeholders, but in a loose way. So several projects were just cancelled. No one really wanted the product. So simple things. As when we talk about the surgeon, they had almost 50% of all deaths that they had before were disappeared by just a simple checklist. And this is a very simple checklist. Are the stakeholders in agreement? Are the stakeholders, first of all? Have you identified them? Are they in agreement? And that is something we often forget, we developers. We think we understand what needs to be done.
Hello. Yeah. Thanks for the talk. I just wonder about efficiency. If you have measured efficiency together with some control group of teams, kind of using this checklist compared to any control group, and what the result was from that, and how you measure it, basically.
Do you want to take it?
Be
honest.
The interesting thing is most of the efficiency will come from the practices that have been selected. The kernel allows you to understand how things are progressing. Probably the most sort of scientific study is the stuff from Carnegie Mellon, where they looked at those 7 people doing individual all at the same time. And there are, I believe, a paper's been published on that. And that's quite interesting. You will look at those graphs on the top right of that slide, and you would make some judgments about what kind of method they're using and who's doing best or not. But what's interesting, it just shows you the situation. So where I've seen this used, what using it does is it helps projects be more successful, but whether it makes them more efficient, there's no real evidence of those kind of efficiency measures. Very difficult.
Okay, so what was the results for the successful rate, then, or how did you measure if a team was successful compared to the other?
Well, like I say, this is about understanding where you are. We did do a lot of work at KPN where they had 14 programs, over 400 projects, and they used a method based on the kernel. They did their QA based around the results. So had you got the result you needed rather than had you done it the way, right? And some projects opted out of working in this way, but everyone was measured not with the kernel, but with productivity measures and things. And the ones that opted out and carried on in the traditional way all did worse in all the measures. They had worse quality, more slippage, and all of those things. Now, you can't attribute that purely to the fact that the others had the kernel involved. There's also the practices. But that's sort of, we have seen that kind of separation. But there's not a lot of, in our industry, there's not a lot of good science done on the effectiveness of methods and practices. The same holds for agility and things like that. So there's a few examples.
Let me add to this that the kernel is just a month old, the standard. We had a kernel in my company and used it, so we have experience from using a kernel. The kernel was that we had is very similar to the standard, by the way. So it's very easy to move. People that were our customers can easily move to the CMAD kernel, even if it worked to us. But what we haven't seen is comparisons. For instance, there are people working with Scrum, and they have now and writing papers about how they experience how much better it will be by using SEMAT Essence as a platform for Scrum. Instead of describing Scrum like in the user's the Scrum guide, you can describe it on top of Essence. You can make a much more concise description, and it's also very easy to find holes in Scrum where Scrum doesn't really support you, that you need some other practices. And but we would like to see that kind of papers, experience reports. It's not yet available.
So in the last part, there was some talk about business practices as well. There was this division into 3 different groups. So is this going to stay a software engineering thing, or are you planning to branch out to practices and all kinds of work in general?
I take it. We have, interesting enough, we decided originally when we started CMAD, we took a hard decision. Should we support more than software development? And we said, we have to make it successful for software development before we go to other areas. And the other areas is typically systems engineering, business engineering, and there are other areas like projects in general. In Russia, there is a group of people that has, from Incosa, which is systems engineering, which has made some minor extensions to the existing kernel to make it applicable for systems engineering. So that is a group of people working on it. There's another group of people also in Russia working on using it for projects in general. So it's not only software products or systems, but any project, any endeavor, human endeavor. And finally, there is a group of people working on using the kernel for education in high school, for high school students in software. So, but this is just the beginning. The interesting thing is that the academic community are really taking on using it, because for the first time in the history of software development, academics can teach what is the core of software development. What is it that we always do? And they don't need to teach a particular method. In Sweden, for instance, One university teaches Scrum, another university Extreme Program, and a third one Kanban. So when people come out and they meet, they're sitting there with no foundation and have to fight to get to some agreement. Have you seen that, by the way? That should be normal. But if you had because there is nothing really fantastic about this kernel. It's just the foundation. We don't need to have a lot of arguments about whether this is the only. It's not the only foundation we could have had. It's one foundation. And if you don't like it, make some changes.
So, I mean, at Fujitsu, they modeled their sales process and other things using this way. What I like to think is that for too long, in software development, we've been looking at other industries and taking their ideas. I think it's time they should start looking at us and taking some of ours. So hopefully, if this is successful within software, then other areas will pick up on it. So it could be generally applicable. But I'd like to see that thing turned the other way around. Because software isn't manufacturing. It isn't building buildings. It's a new thing. And we've got lots of new ideas. Not just us, everyone.
So yeah, you maybe touched on my question with this answer. Do you have an established process for updating the kernel itself? Like not extending on it or updating it for a specific team, but the master kernel itself? Or do you think that it's universally true and will never, ever, ever change?
So let me. Can you repeat it, please?
The question was: is there a process for keeping the kernel, evolving the kernel, improving it, and keeping it up to date? Or
Yes,
do you think it's the one true kernel, never needing to be changed?
Now, first of all, we don't believe there is one true kernel. We don't even believe the kernel we have now is the best one, but it's a good one. Because, as you know, the best may be the enemy of good. So, and then when it comes to changes, this is thankfully now organized within Object Management Group. So they have developed a formal process for changing. And there's already started the next version of a kernel. That work has already started immediately when the standard was taken. So there is work going on identifying problems, coming up with new solutions. So there will be, in maybe 1 year's time, a new version of a kernel. But it's probably not dramatically new, only if there's really dramatic problems, but we haven't heard anything. Actually, we don't hear any problems. We only hear people are doing well. So if you hear and know any problems, please tell us. We would love to hear about them.
Thank you.
It's just a sort of on the softer side of things, but I mean, given that you've had a lot of experience across a lot of different organizations, why do you think it is that software engineers in general seem to have such a hard time arriving at methodologies for developing software? I mean, I myself have experienced multiple different organizations. Every time I go into an organization, there's a huge debate as to how things get done. Lots of things are clearly wrong. And it seems to be very, very difficult to arrive at a good way of getting things done. And it seems to be something to do with the culture. I'm just curious to know what your opinions are on that.
So, did you hear the question?
Yes.
Can you repeat it?
So the question was, why is it so hard to establish a method in an organization? And why do they, when there's obvious problems, why are they so hard to address? Is it just a cultural issue, or is it other forces at play?
Yeah, so it's not a specific question. It's really just I'd like to hear your general impressions, given that you've had a lot of experience across different types of organizations.
Yeah, I can give one answer. I would ask Ian to also add to it. I think the general problem here is that we have so many different contexts. So if you, for instance, every company think they are doing something unique, successful company. If you go to banks, basically every bank think they know better than anyone else. The software people, how to develop software for banks. You go into the defense industry, it's the same thing. Telecommunication. And area after area, people think they have something really unique. And so basically they drown in this, that there is so much context-dependent thing. So what we are trying to do, and if you read our book, you will see on the front page, we quote Michelangelo. Michelangelo is the right pronunciation, sorry for that. When he did David, he got a big block of marble. And he could see David inside that block of marble. No one else saw it, but he saw it. And the only thing he had to do was to chip away the things that were not part of David. That was his only job. And we have paraphrased that and said that we have found the essence of methods and among the mass of methods. And we take away the things that are not essential, that are not universal for all methods. And whereas the people out there, they sit with a particular problem and they have no description, the foundation of what software engineering is. They have a method, they have another method, they have a third one, and they try to do the best of their knowledge. Having this basis where you can stand on top of and then add the things that you think are great will, of course, make it easier.
And just to add to that, the single biggest reason for this is people don't break the practices out. So they think they've got to change the whole method, right? And then they have wars about it.
Yes.
Right, and they try and, they change the things that don't need changing because if I want to do this one, I have to do the others. And then it just churns. They never give people time to mature or experience, and they don't allow the people on the ground to define these things.
To define a method is so much more complex than describing single practices, because every method is the soup of these practices. And that makes it complicated. And also when you create a soup, you want to add a little here, and you want to make it a little unique for you. So we are, to tell a little joke, in the 16th chapel in Rome, Michelangelo, he made the painting in the ceiling. And it was damaged. Some years ago, it was damaged. So they had to fix that damage. They couldn't ask anybody to do it. So they asked El Greco. And he was, so they said to El Greco, you are the maybe most prominent painter now alive. And you see that damage up there. Can you please help us to fix it, repair it? El Greco looked up and he took a step backwards and said, oh, no, I can't do that, but I can repaint the whole thing. And that is very much what people who create methods want to do. And even if there is a good basis to start with. And we need to get away from that. And that is part of what we're doing.
So you built basically a meta language that lets people that speak different methodologies to talk to each other, and you built a way to measure how good they are at what they do. Do I need to improve in the way I gather requirements, or or in the way I address the problem of requirements, not just gathering? What I think it's lacking from this model, as far as I see it, is actually the cultural aspect and the environment where these projects operate. You're gathering a lot of data about how good they are, but not in which areas they are good. Am I working in something that is like a highly regulated industry, like building a software for a airplane, or am I working in a very place where I can be much more take much more risk? And the other side, also cultural things, like I'm working in a society where I have I can address authority easily or not. And I wonder why you are not gathering this kind of data, because it will be extremely useful for the community, the software industry itself, to know if I have to address this particular aspect and I'm in this particular context, then these practices can help me the best across all the things that are ready and available. And once you have the data, it's easy to do the math to figure this out automatically, but there is no one that's gathering this data on a very large scale.
Okay. So I'll let Ian summarize your question.
Take a while.
He's native English-speaking person. I'm speaking Swinglish, so.
The question was about we've defined a kernel and a language for defining practices, and that's good, but are we collecting information about the context in which the practices would work and some of the cultural aspects around things? So we have team as one of the elements in the kernel, so we can collect practices around there and stuff. But is anyone collecting data that would help you understand when it is that certain practices work and when it is that certain practices would be the wrong thing?
That's a very good question. I'll let Ian answer.
I think the simple answer is as part of the CMAT community and the research, we hope that by establishing some common ground, people will do this research, right? And they will gather this kind of data. And hopefully that will start to happen, and as practices get added, people need to say in which circumstances these things are applicable. So we're hoping to build that, and I believe some of the researchers are looking at this in a small way, but there's nothing significant happening. But I would love to see it happen personally, and it's sort of within the remit of the community to look at those sorts of things. But as an industry, we have a total sparsity of that kind of information.
I would like to add to it too, and as you know, CMAD stands for Software Engineering Method and Theory. We have always believed from the start of this that we need to get the academic community to be part of it and not be dominant. I described it that this work needs to be driven by the industry, formulated by the. So I felt we need to have a general theory in software engineering as underneath whatever we do. And there is quite a large group of people now working on a general theory in software engineering. They have meetings every year and present papers, and there will be a special issue in some magazine, I don't remember which it is, about just the general theory in software engineering. What they expect to be able to do is to predict what happens if you have this situation and you remove this practice with another practice. Will it be better? Will it be worse? And similar questions, prediction, which is something we can only do in a few cases right now. So with the academics behind it, we can get better education. We can get at school, so we actually teach something of use at universities. They do that, but maybe it could be more useful what they teach. And also the research, less than 1% of all research in software engineering is ever useful. That is too low number, because they really don't know what to hunt for.
Can you share some experience about application of the methods in a context of geographically distributed teams?
So, yes, I'll let Ian respond to that hard question. Yes,
I mean the ideas and the kernel, certainly the one that we had in IJI, have been used in very large and geographically distributed projects and ones with outsourcing. And by having that common ground and being able to communicate, that brings the parties together. but also you can understand which practices are being done in each location, which practices need to be the same across all the people, and where you can have the variance. So one of our big adopters is a company called Munich Re, and they are all over the world, and they've had to establish some practices that everyone shares because they're part of Munich Re, but they leave holes in this setup for all of those different areas to go their own way. So it can certainly help bring people together and understand what the interfaces are, which bits of the kernel are they responsible for, which bits of the kernel are we sharing, which things are you doing. So we've seen that quite a lot. If that answers your question at all.
Okay, hi. The thing that interests me is you started this talk trying to address the issue, or up to a point, trying to address the issue of a person changing an environment and switching a team, or something like that. So, in two teams that use different methodologies or whatever. So, I'm interested in, have you measured, or do you have some useful data about how does your platform help people change environments and adjust to a new environment better? Because if I understood correctly, that's one of the big issues you're trying to address. And if not, do you have plans to gather some really measurable data about that and run some experiments? Thank you.
So this is really where Ian can based on his experience in working with big clients, Munich Re, KPN, and Fujitsu, and so on. We also have a similar experience in China, where several big companies are working with Essence as a platform.
Well, again, but we haven't really reached enough people to be able to get good enough statistical evidence. Where we've used it in large companies with disparate communities or companies that are bringing in different outsourcers, and having the common ground certainly allows them all to get up to speed more quickly than they've done before. That measure is a qualitative measure. That's what they've said, rather than we haven't actually been in a situation to do controlled experiments or measure those timelines. But we have seen teams coming together and becoming effective and getting on the same page with each other more quickly than we've seen previously. But it's anecdotal rather than measured information.
Any last question? Okay, let's thank the speakers again.
Thank you. Thank you.